Hello viewers, welcome to Big Boy Physics. Today we'll be discussing a problem from Pathfinder Check Your Understanding, question number 1, that is from the chapter of Modern Physics. This question is based on the concept of radiation pressure and force due to radiation, all those stuffs. Okay, so let's get started. The question says an isotropic point light source of S of power P is located at a distance d from a specially designed, non-absorbing, non-dispersing, non-reflecting lens. But a lens is refracting. One thing you must remember. This lens converges all the radiant energy coming from the source into a beam parallel to the optical axis. Okay? This basically indicates that the source is kept at the focus of the lens. Then you have to tell me the magnitude of the force due to the radiation pressure on the lens. Okay, to do this concept you can use one important concept of solid angle, that we know that if we have a circular disc. Okay, we have some kind of circular disc and this is at center C, and from center C we have a point at a line joining the perpendicular from center C to P, that is PC is perpendicular to the disc. Okay, then we say that the solid angle subtended by the disk at point P is given as ohm. Capital Ohm is given as 2 pi 1 minus cos theta. Okay. So basically this is the solid angle due to the circular disk at point. Now here we have to make some small derivations. Suppose I take a small circular thin strap with subtend angle theta plus d theta at the center at the point P. Okay, this angle is given as d theta, that is the line joining the inner disk and the outer imaginary thin disk. Okay, then can you tell me the corresponding magnitude of the solid angle subtended by this circular strap? I have indicated using red shades. Okay, so what will be the solid angle due to this circular strap at point P? Then just simply differentiate. D ohm will be 2 pi sine theta d theta. So this is one small concept we'll be using to solve this problem. So now coming to back to problem, we have some kind of lens system. I am marking with blue color. This is my lens, and the green line represents my optical axis. The red color represents my source. Suppose you consider a small circular strap as I did in the previous with subtend angle d theta. Okay, this is a circular strap. Then can you tell me how much amount of radiation is going through the circular strap? The amount will be considering the energy per unit time. So dp, or d capital P, better to say, d capital P is equals to d ohm by 4 pi into P, where P is the total power. What is d ohm? D ohm, as we have derived, 2 pi sin theta d theta. Then we can write it as P d ohm by 2 sin theta, P by 2 sin theta d theta. So this will give me basically my differential power through this circular strap. Now can you tell me the number of photons passing through it? So number of photons d small n is equals to dp by hc into lambda. You will get p sin theta d theta by 2 lambda by into lambda by hc. So basically this will be the number of photons crossing this lens. Now tell me one thing. Suppose you have one photon emitted from point S along the angle theta with respect to horizontal. After crossing the lens system, it becomes horizontal, right? So can you tell me the change in momentum? Delta P for one photon would be h by lambda into 1 minus cos theta along the x direction. And by symmetric, you can also say that if another photon is emitted at an angle theta in the downward direction, then it will also go straight. Basically, net overall force will be horizontal. There won't be any component along the vertical because all the vertical components gets cancelled. Okay, better write x here. Okay. Now, what will be the change in momentum or the change in momentum per unit time at an angle theta to theta plus d theta, or the differential force df would come out to be p by 2c sin theta into 1 minus cos theta d theta. Of course, it's along the x direction, right? Now, my total force would be just integral this from 0 to theta naught, where theta naught basically represents my this angle. Theta naught is the angle between the tip of the lens, that is the end point of the lens, and the horizontal line. Hope you get it. Well, sine theta naught, we can write it as r by under root d square plus r square. Cos theta naught will be d by under root d square plus r square. Is basic trigonometry rules. Now just doing the integral, you'll get p by 2c integration of sine theta minus sine theta cos theta can be written as 1 by 2 sine 2 theta d theta, and further evaluation it will result you p by 2c integral of sine theta is given as minus cos theta, and this minus 1 by 2 sine 2 theta can be written as plus cos 2 theta by 4. Now you have to evaluate it from 0 to theta naught, where theta naught is my required value. Finally, we will eventually end up with uh, 1 minus cos theta naught plus cos 2 theta naught minus 1 by 4. We can write this expression to be minus 2 sine square theta naught, right? So substituting all those, 1 minus cos theta naught is under root d by under root d square plus r square, and minus sine theta naught square by 2. But sine theta naught I already derived r by under root r square plus d square. Putting that value only, r square into by r square plus d square. Okay. And since we are interested in the magnitude, we'll just keep a mod sign at the last. Hope you get it. So that's the final answer. Well, in Pathfinder, they have given a negative sign. Means the answer which I am getting is actually a negative of that. But since we are interested in the magnitude stuff, so we just put a mod here. Well, it doesn't matter much. Okay. Hope you learned something new from this video and enjoyed solving this problem. Thank you. Have a nice day and stay tuned.